Hello, Honors Algebra 2. So we are going to start the Chapter 1 test study guide. So get excited. I'm probably not going to do the entire thing in this video since it's kind of a lengthier study guide. Who made this? But we'll get through as much of it right now as we can. Okay, so first thing we have, number 1 is simplify. So this is from R7, which is simplifying rational functions. So the first thing we need to do on both top and bottom is we need to factor. So 4x cubed minus 36x, the first thing I recognize is that I can factor out a GCF from there. So I'd factor out a 4x, and I'm left with x squared minus 9. And then on bottom, I'm looking, okay, 2x to the 4th minus 24x cubed plus 54x squared. Well, from every single term there, I can actually factor out a 2x squared. And then I'd be left with x squared minus 12x plus 54 divided by 2, which is 27. Now, I want to make sure, is everything fully factored? And it's not. X squared minus 9 is a difference of squares, and x squared minus 12x plus 27, I can factor that further. So let's keep factoring. So 4x, and then that becomes x plus 3 and x minus 3. And then the 2x squared stays there. And then the two numbers that multiply together to get me positive 27 and add to get me negative 12 are negative 9 and negative 3. So because a is equal to 1, I can do x minus 9 and x minus 3. I don't have to split the middle term. And so now that it's fully factored, I can start to cancel out any like terms. So I look to see, is there anything exactly the same? X minus 3 and x minus 3, those can cancel. Same like variables and numbers, and same sign too. And then I can look at the numbers, 4 and 2. Well, we can simplify these because really it's 4 times x, and this is 2 times x squared. So 4 and 2, that's like simplifying 4 over 2, just like a fraction. And so I can simplify that to be 2 over 1. Now I can also simplify the x's. X over x squared can simplify to be, this x is gone, or just 1. And then this x would become x to the first power. So what's left? Well, on top, 2 is left times x plus 3. We're not going to multiply that out because I do want you guys to leave it fully factored. And then on bottom, we have x and then x minus 9. Same thing. We're not going to multiply it out. We're going to leave it fully factored. I double check one more time. Is there anything else that can cancel? And there isn't. Is there anything else that I can factor? There isn't. So we're good to go on that one. Okay, so number 2, we have an entire fraction over another fraction. So the first thing I'm going to do is rewrite it. So when I rewrite it, I'm rewriting it as 15x squared minus 6x divided by 5x squared minus 17x plus 6. And then divided by, so this we're going to write as divided by 9x cubed plus 18x squared all over x squared minus 9. I've got to make sure I wrote that right because who knows. So make sure you copied it down right. Looks good. And now I can start the process. So first step, whenever we're dividing, and I have one fraction on the left and one fraction on the right, I'm going to flip the second one and multiply. So it becomes that whole thing again. But now we're going to multiply the reciprocal, x squared minus 9 over 9x cubed plus 18x squared. And then we factor. Now here, here, and here, those are all pretty easily factorable. But what I'm going to do is I'm going to factor this one on the side over here because that one I do have to split the middle term. I have to split the middle term on that one because a is greater than 1. So it's just easier if I just kind of do it on the side. So I'm thinking what two numbers multiply together to get me 30 and add to get me negative 17, and that's negative 15 and negative 2. So I split my middle term, 5x squared. What goes better with 5, 15, or 2? And 15 does. Minus 2x plus 6. And now I can factor by grouping. So from 5x squared minus 15x, I can factor out of 5x, and I'm left with x minus 3. And then from negative 2x plus 6, I can factor out a negative 2, and I'm again left with x minus 3. Remember, if these are not the same, then you've done something wrong. Go back and check your work. So fully factored, it would be 5x minus 2 times x minus 3. So now that that one's factored, we can go through and kind of factor everything else. So from 15x squared minus 6x, I can factor out a 3x. That's just a GCF, and I'm left with 5x minus 2. Here I have 5x minus 2 times x minus 3. X squared minus 9 is a difference of squares, so I can write that as x plus 3, x minus 3. And then 9x cubed and 18x squared, I can factor out a GCF of 9x squared, and I'm left with x plus 2. And then from there, I start to cancel. So what can I cancel that's the same? So 5x minus 2 and 5x minus 2 are exactly the same. I can cancel those. X minus 3 and x minus 3 are exactly the same. I can cancel those. X plus 3, there isn't anything down here. X plus 2, there isn't anything up there. Then I look at my numbers. 3 and 9, I can simplify those. 3 goes into 3 one time. 3 goes into 9 3 times. And then x and x squared, I can also simplify those. So x, that goes away, and this becomes x1. So then I just look to see what's left. So on top is just x plus 3. And on bottom is just 3x times x plus 2. And that's it. Remember, these cannot cancel, like this 3 and this 3 can't cancel because this is x plus 3 and this is 3 times x. So those are not the same. Okay, so still in R7 here. Let's move on to number 3. So number 3, kind of similar that up here where we have a fraction over a fraction. So the first thing, just like I did in 2, I'm going to rewrite this. So 8 plus 4 over x divided by 2x over 5 minus 1 over 10. So the trick here when we have like a fraction, like a mess kind of on our left and then a mess on our right, is we want to get these so they are both each one individual fraction. And so we do that by getting a common denominator. So I'm just going to first ignore the right side completely and just look at the left side. And so I look at my denominators, 1 and x. And so the common denominator between 1 and x is x. This is already x, so I'm just going to multiply this by x over x. So I have 8x over x plus 4 over x. Now that we have a common denominator, I can combine the numerator. So 8x plus 4 over x. So now that I have a singular fraction on my left, now I can start to deal with the fraction on the right. So again, I want to get a common denominator. So between 5 and 10, my common denominator would be 10. This is already 10. To make 5 10, we're going to multiply it by 2 over 2. So that's going to be 4x over 10 minus 1 over 10. And so now we can have a common denominator, so I can write it as 1, 4x minus 1 over 10. So I have one fraction on the left, one fraction on the right. So now I'm at the same spot that I was in 2. I can flip and multiply. 8x plus 4 over x, and then multiply the reciprocal, 10 over 4x minus 1. I'm going to factor this. So if I factor out a 4, that would be 4 times 2x plus 1 over x times 10 over 4x minus 1. Now, unfortunately, nothing can cancel. So if you were to write it as 10 times 8x plus 4 over x times 4x minus 1, that would be fine. Or if you wrote it as 40 times 2x plus 1 all over x times 4x minus 1, that's fine too. So whatever way you want to write it is totally fine. Just to, again, keep it fully factored. So don't multiply everything out. Okay, let's keep going with the next problem. We're still in R7. This is the last problem from R7, and it is a subtraction problem. So remember, with these types of problems, I really encourage you guys to follow the steps. So our first step when adding and subtracting a rational expression is to factor the denominators. So x squared minus 4x minus 45, so the two numbers that multiply together to get me negative 45 and add to get me negative 4 are negative 9 and positive 5. This is already factored, so I don't need to worry about that at all. So what I do need to do now that it's factored, I want to figure out what's my common denominator. So I first figure out, okay, what do they have in common? And they both already have an x plus 5. But this has an x minus 9 that this one doesn't. So what we need to do is multiply this by x minus 9 and x minus 9. This didn't have anything extra that this didn't have, so I don't have to multiply this side by anything. So at this point, we completely multiply first. So remember, you're completely multiplying the top. So that's x squared minus 9x over, x minus 9. I didn't mean to write that x again. Times x plus 5 minus, and then we multiply 2x minus 18 over x plus 5 times x minus 9. Now are the denominators the same? They both have an x plus 5. They both have an x minus 9. We're good. Now we can combine the numerator. Remember, when we're subtracting, this is the most common mistake. You guys forget to distribute that negative. So that minus has to go to both the 2x and to the negative 18. So that becomes x squared minus 9x minus 2x plus 18. And then we can combine negative 9x and negative 2x can combine to become negative 11x. And now we can write it as one fraction. So my next step from here is to factor. So do I know two numbers that multiply together to get me positive 18 and add to get me negative 11? Well, I do. It's right here. Negative 9 and negative 2. I'm going to move my work up here. So that would be x minus 9 times x minus 2 all over x minus 9 times x plus 5. And now, and only at this point, can you start to cancel. And so I look to see, are there any like factors? And there are. X minus 9 and x minus 9 can simplify. X minus 2 and x plus 5 cannot. So that's my final answer. And that does it for R7. So we are going to move on to the questions from R8, which is starting with 5. So on number 5, you are rationalizing the denominator. It doesn't say that, just says simplify, but you are supposed to know that, okay, when there's a square root in the denominator, we've got to get rid of that. So remember, what we do is we multiply by whatever's in the denominator, but we just flip the sign. So it's 5 minus rad 2 over 5 minus rad 2. And then the biggest thing is just take your time when you're multiplying. So 2 times 5 is 10. 2 times negative rad 2 is negative 2 rad 2. 5 or negative rad 3 times 5 is negative 5 rad 3. And then negative rad 3 times negative rad 2. Well, first, the negative and the negative can multiply together to get me a positive. And then the rad 3 and the rad 2, because they're both on the inside of the square root, that becomes rad 6. Okay, and then it's all divided by, and then we do the same thing. 5 times 5 is 25. 5 times negative rad 2 is negative 5 rad 2. Rad 2 times 5 is 5 rad 2. And rad 2 times negative rad 2 is negative 2. So remember, your whole goal here is to get rid of the square root in the denominator. So did I do that? Negative 5 rad 2 plus 5 rad 2 is 0. So I did do that. So then I can combine anything that's alike, which unfortunately on the top, there really isn't anything that you can combine. Rad 2 can't combine with rad 3, and it can't combine with rad 6. So the only thing I can do is combine 25 minus 2. So my final answer here is 10 minus 2 rad 2 minus 5 rad 3 plus rad 6 all over 23. Not the prettiest answer, but that's it. Okay, so let's look at number 6. So number 6, we are simplifying. So remember, to start this process, we always want to simplify the radicals if possible. So rad 24, let's just look at that first. 24, I'm thinking, what's a perfect square that goes into 24? And we know that that's 4 times 6. So that means rad 24, we can pull out the 2 and leave the 6 there. And so that would simplify to be 2 rad 6. Now, what about 54? What's a perfect square that goes evenly into 54? Well, I know that's 9, and 9 times 6. So the square root of 9 we know is 3. So the 3 can come out, and then the 6 stays in, which then makes it nice because then it's like radicals. So the 9 stays out, and then in place of rad 24, we write 2 rad 6 minus 15 times 3 rad 6. So remember, if they're both on the outside, like 9 and 2, those can multiply together. 9 times 2 is 18, and then you leave the radical as is. And then 15 times 3 is 45, and then again, you leave the radical as is. So then once those are like radicals, which they are, we can just add or subtract the front numbers. 18 minus 45 gets me negative 27, and then leave the rad 6. And that's your final answer. Okay, so let's look at number 9. Number 9 is taking the square root of 48x squared, y to the 5th, z. So with that one, what I typically do, now that's the square root. So our index number there is 2. Now I'm just going to look at this piece by piece. So I'm first going to look at rad 48. And then I'm going to look at x squared, and then y to the 5th, and then z. So first, 48 is just like how we dealt with up here. So I'm thinking, what's a perfect square that goes evenly into 48? Now, originally I want to think 4, but I can actually use a bigger number because 12 can be split up again into 4 and 3. So 48 is actually, the perfect square is 16 times 3. And so then we know the square root of 16, and then 3 is going to stay inside. So that would become 4 rad 3. Now, with variables with exponents, the nice and the quickest way to do this is always take the index number, which our index number is 2, and divide it by the exponents. So 2 divided by 2 is 1. 5 divided by 2 is 2 with a remainder of 1. And 1 divided by 2, well, it's 0 with a remainder of 1, right? So what that means is when we have 1, 1x can come out with none left inside. With y to the fifth, 2 y's can come out with 1 y inside. So the 2 comes out, the remainder stays inside. And then with z, none come out, and the 1z stays inside. So then to write it as 1, we just write everything that's on the outside first. So 4xy squared. And then everything on the inside together, 3y and z. And that's your final answer. Okay, let's look at number 8. So we have 81 to the 3/4 power. So with that, remember a fractional exponent, the bottom is always like the root. So this would be saying the 4th root of 81. And then the top, the 3, is the exponent. So to the 3rd power. So the 4th root of 81, I'm thinking what times itself 4 times gets me 81? And that's actually 3. And then 3 to the 3rd power is 27. And that's it. Let's keep going. Okay, so we are on 1, now. So with 1, we are going to solve in the real number system, and it says remember to check your answers. Super, super important. You want to make sure when it says to check your answers, you are checking your answers. Because remember, we can't have a denominator that equals 0. So with these, the first thing we want to do is we want to, now that there's an equal sign, which is different than 1, 2, and 3, where there were no equal sign. When there is an equal sign, that's when we want to clear the denominators. So what I'm going to do is I'm going to look to see what did they all, I'm just going to first factor them. So x squared minus 4 is x plus 2 and x minus 2. Same here, x plus 2, x minus 2. I should write smaller. And then this is factored. So to clear my denominators, what I'm going to multiply it all by. So this one has an x plus 2. So I'm going to definitely multiply it an x plus 2. And then this one has an x minus 2. So I'm also going to multiply it by x minus 2. We already accounted for the x plus 2. We already accounted for the x minus 2. We already accounted for the x plus 2. So this is all we're multiplying it by. So let's multiply. So I'm not going to write my extra step, but I'm going to talk it through. So 2x over x plus 2 and x minus 2, when we multiply it by this, everything is going to cancel. X plus 2 and x plus 2 and x minus 2 and x minus 2. So the only thing that's going to be left is 2x. Then equals, and then x plus 2 and x minus 2, those are again both going to cancel, and I'm just going to be left with 4. Now with this one, x plus 2 and x plus 2 are going to cancel, but I'm left with minus 3 times that singular x minus 2. So now that I've cleared my denominators, now this is a pretty simple problem. I just have to first distribute my negative 3. And I get 2x equals 4 minus 3x plus 6. Combine like terms. So I can combine the 4 and the 6 to get me 10. Add 3x to both sides to get 5x equals 10. And then divide both sides by 5, and I get x equals 2. Now remember, I have to check my work. So when I do that, let's check. I'm plugging it back in. So 2 times 2, doesn't really matter about the top, but 2 squared minus 4 equals 4 over 2 squared minus 4 minus 3 over 2 plus 2. Now, what is 2 squared? Well, 2 squared is 4. 4 minus 4 is 0. Same with here. Doesn't matter that it's twice. If it happens once, that means this is not a solution. So that's the only one that we found. So that means this is no solution. Okay, so number 10 is similar to number 9. It's the same type of problem. So the first thing I'm going to do is I'm going to factor x squared plus 4x minus 12. Now the two numbers that multiply together to get me negative 12 and add to get me 4 are x plus 6 and x minus 2. So I'm going to multiply, because I have that equal sign, I'm going to multiply everything through by the common denominator to clear the denominators. So I look at my first denominator, I have x minus 2. Okay, I have x plus 6. I have an x minus 2 again, I've already accounted for that, and an x minus 2 again, I've already accounted for that. So we're good here on what we're multiplying it by. Okay, so x minus 2 and x minus 2 are going to cancel on my first term. So all I'm left with is 1 times x plus 6. And then minus 5. That x plus 6 and the x plus 6 are going to cancel. The x minus 2 and the x minus 2 are going to cancel. So there's nothing being multiplied there. Equals 6. The x minus 2 and the x minus 2 are going to cancel. And it's just going to be multiplying by the x plus 6. So again, once we clear the denominators, it becomes a lot more straightforward of a problem. And so now I just have to distribute, which we're not really distributing anything there, but we are distributing the 6 there. So it'd be x plus 6 minus 5 equals 6x plus 36. Combine my like terms on the left, 6 minus 5. So that's x plus 1 equals 6x plus 36. Subtract 6x from both sides to get negative 5x. Subtract 1 from both sides to get 35. And then I get my final answer to be x minus 7. So now we just have to check your work. So we have to go through and make sure that that negative 7 doesn't make any of my denominators 0, which you can just do that like kind of as a mental check, but let's still write it down to remind ourselves. So 1 over 7 minus 2, we're good there. Oops, minus 5 over negative 7. Oh, that's supposed to be negative 7, but still good. Plus 4 times negative 7 minus 12 equals 6 over negative 7 minus 2. Now we could plug this in, but I know, okay, negative 7 plus 6 is negative 1, and negative 7 minus 2 is negative 9, so they're both not equal to 0. So we're good. That is my solution, x equals negative 7. Okay, so that does it for 1-1. I am going to pause us here, and we'll pick up with the rest of the problems in another video. So take a break, do what you need to do, and there you go.